first section in Chapter 9 is titled Powers and Exponents. We want to be able to write expressions using exponents and also evaluate expressions that contain exponents. So let's first talk about an exponent. An exponent tells how many times a number is used as a factor. A power is a number that is expressed using an exponent. And the base is the number that's being multiplied. So for the example here, we have 5 to the third. So the 3 is the exponent. The 5 is the base. And the 5 to the third power, the whole number itself with the exponent, is the power. So remember what this means. Let's look at a chart. And you don't need to write this down, but please follow along. So this is how we read and write powers. We write 3 with a power or an exponent of 1. We read that as 3 to the first power. Essentially what it just means is the number 3. If we have the base of 3 with an exponent of 2, we say it's 3 to the second power. And another way to say a second power is 3 squared. You'll hear me say 3 squared often when we have an exponent of 2. But what that means is 3 times 3. Then we have 3 with an exponent of 3. That's 3 to the third power, or 3 cubed. So that's 3 times 3 times 3. This continues on in the same pattern. Essentially, the exponent indicates how many times that number is being multiplied by itself. So let's write each expression using exponents. Here on number 1 we have 4 times 4 times 4 times 4 times 4. We have 4 being multiplied 5 times. So we have a base of 4 and it's being raised to the 5th power, or 4 to the 5th. Number 2, we have negative 8 times negative 8. So we have a base of negative 8, and it's being squared, or being raised to the power of 2, because we have negative 8 being multiplied times itself twice. Number 3, we have 6 times 6 times 6 times 6. So that's 6 to the 4th power. And in number 4, we have 1/2 being multiplied 3 times. So it's 1/2 to the third power, or 1/2 cubed. We can also do the same thing, write the expression using exponents, when we have variables. So essentially you're just counting how many times the variables being multiplied together. So y times y times y times y times y times y times y, that's y to the 7th power. We can also use an expression like k plus 2. We have k plus 2 being multiplied 4 times. So it's k plus 2, keeping it in parentheses, to the 4th power. We can also write expressions using exponents when we have different variables. So we have 5 times r times s times s times s times s times s. We'll notice that this r times r is r squared, and the 4 s's are s to the 4th. So when we simplify this expression, we have 5 r squared s to the 4th. Number 8, we have x times x times x, so that's x cubed, or x to the third, and y times y times y, which is also y to the third. We also want to talk about the order of operations. Because powers represent repeated multiplication, they need to be included in the rules for order of operations, and you do need to write these down. So first you want to simplify the expressions that are inside grouping symbols first, so inside parentheses or brackets. Then you want to evaluate all the powers. Then we do multiplication and division, left to right, and then addition and subtraction, left to right. So let's simplify the expression. 2 to the 7th. Remember what that means. It means 2 times 2 times 2, 7 times. And we want to simplify this. Well, what is 2 times 2 times 2 times 2 times 2 times 2 times 2? Well, 2 times 2 is 4, times another 2 is 8, times the 4th 2 is 16, times the 5th 2 is 32, times the 6th 2 is 64, and times the 7th 2 is 128. Make sure you understand this is not 2 times 7. This is not 14. This is 2 multiplied 7 times. So that's 128. Number 10, we have 2 squared times 3 squared times 5. Remember, 2 squared is 2 times 2. 3 squared is 3 times 3. And then times 5. In multiplication, you can do it in any order. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. So now we need to do 36 times 5. And 36 times 5 is 180. Now let's evaluate some expressions. So we're going to have an expression in variables with variables and exponents, and we need to evaluate. So for number 11, we're evaluating x squared plus y squared if x equals 6 and y equals -2. So all I'm going to do is substitute in the numbers. So instead of x squared, we're going to have 6 squared. And I like to use parentheses, and you'll see why in a minute, but especially in the case of negative numbers. So then 2, -2 substituting in for y, also squared. 6 squared is 6 times 6, that's 36. Plus -2 squared, that's -2 times -2, which is a +4. 36 plus 4 is 40. So evaluating x squared plus y squared if x equals 6 and y equals -2 gives us 40. Let's look at 2 more examples. Now let's evaluate the expressions if a equals 5 and b equals -2. And if you'd like, you can try both of these on your own. So we have 10 plus b squared. So 10 plus b is -2. So I'm taking -2 and I'm squaring it. I'm substituting in the -2 for b. That's going to give me 10 plus 4. -2 times -2. 10 plus 4 is 14. Number 13, we have a plus b, quantity squared. Remember, order of operations says you do need to take care of what's inside the parentheses before the exponent. So we're going to plug in 5 for a plus -2 for b. And then we want to square the whole thing. And we need to take care of the inside first before we square. 5 plus -2 is 3. Now we square the 3 and get 9. Make sure you understand that order of operations and why it worked that way. So can you write expressions using exponents? Those were examples 1 through 8. And can you evaluate expressions that contain exponents? Examples 9 through 13. Make sure that if there's something that's not clear that you're asking questions in class, and we'll work on worksheet 9-1.